So Sharath, what is this lazy learner? And if it is lazy, why are we even learning about it? So can you just
Yeah, no. Yeah, like me, probably it is lazy. Um, See, the
Yeah,
point
I
is,
made a joke about what lazy learner, why you were learning. Sharath made an even bigger joke that he's lazy.
no, I'm truly. And see, the point is, when we try to bring up the patterns, ultimately all these algorithms that we are trying to use, basically to bring identify some hidden kind of a pattern which explains how your variable of interest is getting affected by the other factors. And there are many techniques as we were discussing, right? So one of these variations are called as shallow methods, right? Shallow techniques. We don't always have to go for statistical equations, right? Or heavy mathematical or statistical equations to try and grab the pattern. So we have this lazy learner, which is also the famously called the KNN method, the nearest neighbor method, which it is a very simple distance-based algorithm, which looks at, hey, if you are close to me, that means you also have similar properties, right? So that kind of a algorithm. And this is one of the simplest algorithms. If you ask me, for my opinion, among all the different techniques that we have in the machine learning or data science world, KNN would be the easiest concept that anyone can learn, right? So it's that easy. And the problem is it doesn't converge. I mean, it doesn't learn the patterns. It is a simple distance based logic. And it is called as lazy because of that, right? It's not able to identify the pattern in the first place. And yeah, the problem is that it is simple distance based. And I mean, you I don't know how to explain these points. If you see, it's called as lazy for a reason, that it doesn't have too much of mathematical or right statistical rigmaroles that we have to really worry about. Simple distance based, right? So yeah.
Yeah. All right. So before we proceed any further, we have a question from one of the participants. I think before also we've used the word vanilla model, and I think we've assumed that people will understand that. So yeah, would any of you want to take it up and explain it? Bharani, maybe you can explain what vanilla means in this context, and also answer the question about the lazy learner, your inputs on that.
Sure, absolutely, Nathan. So, yep. So, vanilla model usually means you use the model with all the default hyperparameters. That means if you just say KNN and give your inputs and outputs within the code of the Python, then it would select all the hyperparameters, but all these hyperparameters would be default values. Okay, so if you end up using default values or default hyperparameters or attributes within your model, then it's called as a vanilla model. That's a regular term that we use. Okay, going back to our lazy learning concept, right? Students usually, including me and a lot of people, are lazy. That's called as student syndrome. What do you mean by lazy? You will upfront at the start of the course or at the start of your academics, you'll decide that, hey, I need to, on a daily basis, study for the exam. I need to prepare very well and get above 90%. But eventually, what will happen? The fire will die down because you know that the exam will be after 1 year or after 6 months. Then you will eventually feel that, okay, 1 week before, I will sit down in a very, disciplined manner. I'm going to go through the entire syllabus. I have to get 80%. But eventually, that also would not happen. Until you know that tomorrow is the exam, that seriousness doesn't creep in, right? And the students become lazy. And KNN works exactly in a similar fashion, wherein until there is a new data point, until you need to do a prediction for that. Given a new data point, meaning given the age, gender, income, interest amount, loan amount, etc., you have to classify whether that person will default on the loan or not. Until you get that, the algorithm doesn't work. Only once you get the new data point, from this new data point, you calculate the distance to all of your training data points and then decide whether a person will default or not. So you wait until the last moment, you wait until you get the new data point, only then your algorithm will kick off. And hence it is also called as non-parametric. There are a lot of algorithms which will run on the training data. It will formulate a math equation and keep it handy for you. And the moment you have the new data, you need not retrain on the training data. You just pass it through the math equation and then you get the result. Whereas in KNN, until and unless you calculate the distance from this new point to all of your training data points, you would not be in a position to predict the output. This is the prime reason why KNN is called as lazy learner.
So I my take for the lazy learner is I would rather say it is a dumb model rather than lazy learner, that it is doing the same process multiple times and not remembering anything, doing the entire thing again. So I would prefer to call it that way. If you have 100 test records, for every test record, it is going through the entire training data, understanding the distance metric. Then second test record, when it is coming to that, again, the entire process, it goes on till the 100th. It learns nothing. I mean, what did you learn? When you touch fire, the first time you learn, don't touch fire. But this model is so dumb, it doesn't do it. All right. So that is the way I kind of explain what lazy learning is. Thank you, Bharani and Sharat, for the insights there. On that note, we'll continue a little bit more about the lazy learning itself. All right. So we have predominantly the Bayesian classifier and the KNN, and also to a certain extent the decision tree. Again, me and Sharat argue on that, but okay. So we'll discuss about the Bayesian classifier, and I would try to understand what are the limitations of the Bayesian classifier. Again, Sharat, you can go first, please. Why is it not very popular?
I would not say it is not popular. I would not agree on that terminology. I mean, that statement. It is quite popular, and the algorithm itself is depending on the Bayesian rule, right? Knight Bayes, and this is something everybody learns in their primary, or I should say their academics, right? Probably their 9th grades, 10th grades, around that. So it becomes very, very pivotal, very, very important algorithm. And it is purely based on the probability and likelihood. In other words, I would also call it as a conditional probability. The challenge would become if you have too many factors, extracting the dependency kind of gets calculation heavy. And it also has the zero probability challenge, especially because if you're training data and test data, that means you have a new data that it's coming in. If it doesn't have a factor that you already have, all right, then yeah, obviously it may not be able to tell you what is the probability. So it purely depends on the historical data, right, and it doesn't learn anything new when new data comes in. So we get kind of a zero probability problem, and that is one gray area here. And of course, we will have something called as Laplacian smoothing to counter that, but that's a different point altogether. So to answer your question, yes, Knight Bayes is not, from me at least, it's not unpopular. It's kind of a popular algorithm, and it is purely based on probability and likelihood.
Okay, so like I said before also, till the foundation levels are there with reference to statistics, with reference to interpretation, with reference to pre-processing, I think the world is in agreement with each other. We three are data scientists, and we've worked together in the same company, and we don't agree on certain things, all right? So that is the beauty of the machine learning models. generally speaking, right? Somebody says this is better because of the experiences they have had with that particular, that particular aspect. So yeah, that is essentially the thing that I wanted to, provoke the people on that and try to get their perspective on that. So yeah, Bharani, your take on knife base and its usefulness or lack of usefulness, whatever stand you decide to take.
Okay, sure. Even gods have feet of clay. Given this context, no algorithm is foolproof. You will have its strengths and weaknesses. You will have the pros and cons. You will have to judiciously pick up the right algorithm and start using that. And a few of the strengths with respect to knife-based algorithm is that it works very well when you have textual data. And when you have textual data, and then you have a classification model as well. For example, you have the emails. On Gmail, you keep getting emails. Those emails should be basically classified as spam or social or promotional or going to inbox. When you have this kind of scenario, knife-based works very well. So given the text data, when you want to pre-process that and when you want to apply a prediction model technique on that. However, it has its flip side as well. And the flip side is that it expects the features to be independent of one another. Probability. Okay. When you do that calculation, it expects the features to be independent of one another. And that's not the case. In most scenarios, your features that you have would be dependent on one another. You cannot have features which are completely independent of one another. And second disadvantage is that it doesn't work well if you have large number of numerical features. Given that, once again, you need to calculate the Bayesian probability. By applying your Bayes rule, you need to calculate the probability. Given that if you have numerical data, large number of those features, it doesn't work well. Right? So these are the disadvantages and advantages. But once again, as I've told you, it's all about experimenting. For what kind of data, what kind of algorithm really works well, we cannot say upfront. Not me, not anyone, even God cannot say with confidence that this algorithm will work on this data set, apply that, right? So we have to experiment and only then can you figure out. And we all are lucky, right? Because it's not as difficult as doing your education. In education, you do your BTech in mechanical, BTech in civil, BTech in electrical, BTech in electronics, BTech in computer science, then decide which suits you. You cannot really do that kind of experimentation when it comes to your education. But when it comes to machine learning algorithms, you always have the provision to experiment. Yeah, thank you.
Yeah, adding a little more on that on a humorous note, it's a good thing that we don't have a very rigid mapping for this data, this model, this data, this model. Because if we did, I think this interview session would have been redundant. All right, we wouldn't have anything. You have somebody would have created the cheat sheet. You pick it up, okay, this data, take this model, done it, you are done, the job is done. It is because that there is opportunities for improvement. The best of the best data scientists will give something. You can take that and work and make something even better is what creates the opportunities for data scientists and the demand that is very much there. So that is another take on that. So yeah, we will agree to disagree on which is the best. We will continue to agree to disagree on which is the best model. Thank you so much for that insight there, both of you, Bharani and Sharath. So let us go back to the decision tree, and we'll restrict our discussion to only decision tree. We just have a couple of minutes. I will give it to Bharani to speak about it. So in your opinion, not going into the ensemble techniques or random forest, how best have you managed to squeeze or change the levers and improve the accuracy and explainability of decision tree, in your opinion?
Okay. Yeah. So number one point is that decision tree has explainability inbuilt into that. So even for a layperson, the moment they look at the rules, it will say that, okay, the new customer has applied for the loan. If the age is less than 30 years, if that person is female, if that person is a postgraduate, if that person's income is greater than $10,000, that person will not default. In that way, rules will be, popped out of decision tree algorithm. So even for a layperson, it would be very clear. Even from a business user standpoint, it makes a lot of sense. Point two is decision tree is also used for feature selection. So if you have, huge laundry list of inputs or features, then you can shortlist the key features from that by looking at information gain, which would give you how much information is contained in each and every variable. So alongside having the explainability, decision tree also has a capability to help you shortlist the important features, right? So, and we have a series which is planned in the subsequent weeks, wherein we are going to pick up each algorithm and we'll delve deeper into that. And the third point is that I think decision tree is a next algorithm or the algorithm next to neural network, which has a huge number of hyperparameters. And people would ask questions, in an extensive manner in interviews when it comes to hyperparameters within decision trees. You'll have pre-pruning, post-pruning, you'll have a lot of other techniques, and you'll have a lot of hyperparameters in that. One has to be aware of what does each parameter do and what is the default value of each parameter, right? So, yep. So these are a few points that I wanted to bring to light, Nitin.
Yeah, thank you, Bharani, and pretty concise and at the same time informative information you've given about, excuse me, the decision tree and how enormous or how big it can be, and it can give explanations to that.